Welcome back, Cat 31 class. We're going to go over the U-joint, top U-joint. See this one shown here on the left. I'm going to go ahead and open it on its own window. So all I need to do is right click, open a new window. By the way, if you ever want to see more than one window at a time, you can always go to Window, Vertical, and I can see both at the same time. I can jump between windows. Notice the one that's active is shown in blue around the border. Alright, so I'm going to focus on the top U-joint. I'm going to go ahead and maximize this, or I can always double click on the frame. Double click on the frame to maximize. Alright, so let's go ahead and take a look at this problem. This one has a lot more features than the swivel that we did in the previous video. Alright, so let's go ahead and take a look at our first feature, which is pad 1. A feature can be a pad, extrude, hole, fillet, chamfer. So those are the details, right? So these are features we're creating. Okay, so let's right click on pad 1, define, and there's the starting point. Okay, so we're going to create our sketch for our first pad. Let's double click on the sketch. Alright, so here's our sketch. We have 2.5 for this length with the radius of 175. We have a 1-inch length here from the origin. Same thing on the opposite side. And we have a thickness of 0.75. Okay, so let's go ahead and create that sketch. Okay, so let's create a new part. So make sure you are in the correct workbench, part design workbench. Oh, I forgot to exit the sketch on this one, so let me do it again. Go to part design workbench, and it'll take me to a new session, and I'll call it top U-joint. And I'll call it number 2 because I already have the existing one. Alright, so I'm going to hit OK. It'll start a brand new session, right? So we're going to do top U-joint number 2, and we are in the correct workbench. Let me reset my my tools. I'm going to right click on any icon. Go all the way down to customize. Go to the toolbars tab, restore position of all toolbars to the default position. Okay, and close, and everything goes back to where it's supposed to go. And again, if you can't find a toolbar or a command, just dig them out, right? You can always start a new one. Here it is, create a new column. Alright, so let's go ahead and start. So I want to follow the same sketch as the previous one, so let's go back. Okay, so by the way, if you ever want to know what sketch something is attached to, like sketch 2, right? You can always right click, go to parents and children, so it gives you a history of what this is connected to. So I'm going to zoom in. So here's our sketch, right? Sketch number 2, and its parent is the YZ plane. Okay, so the YZ plane. So this sketch was created on the YZ plane. So the YZ is the grandparent, the sketch is the parent, and then pad 1 is the child. So the child depends on the sketch, and the sketch depends on the plane. If the plane is somehow deleted, actually we cannot delete the existing XYZ planes, right? Any new plane you create you can delete, but these will cannot be deleted. Okay, so if we were able to delete this plane, then the parent and the child can no longer exist. Okay, so they all depend on the YZ plane. Alright, so on the YZ plane we're going to create our sketch. Let's double click. Alright, so I'm going to go window vertical. Now the assembly, I don't need the U-joint assembly. So I can actually close this. If I need to open it later, I'll open it later. I'm going to go ahead and close it. It's telling you, hey, you're changing something, the U-joint. Are you sure you want to close this? Yes. Or do you want to make any saves? No, I'm just going to say nope. Okay, so once again, let me go window vertical, window vertical. Okay, so I'm going to keep this one here as a reference just to speed things up on this video, so I don't have to click back and forth like I did on the previous video, the swivel. Alright, so once again, on the YZ plane, we're going to create our sketch. Alright, so let's go ahead and create our shape. Alright, I'm going to show you a different way than what the textbook used. I'm going to take advantage of using go to the rectangle, go to the drop down, and I'm going to use elongated hole. One of my favorite commands because it does a lot in one shot. So I'm going to just guesstimate the distance, and by the way, we are in inches. If you're not, make sure to change it to inches, but it's okay if you decide to type in millimeters. I'm okay with it. Alright, so I'm going to click. I'm going to create my profile for the inside. There it is. And we have a 1 inch dimension. So all I have to do is change this one to 1 inch. There it is. Okay, and we have a height. So the height from the horizontal to the center point is 2.5. Okay, so I'm going to type in a dimension. I'm going to go back to my new sketch, put a dimensional constraint from the horizontal axis to the center point. Okay, and let's change it to 2.5. Alright, now I actually don't need this circle, or my mistake, this arc, so I can always change this to a construction element. You can click on it and change it to a construction element. There it is. Hey teacher, I can't find my sketch tools. If you can't find it, most likely you accidentally turned it off. So you can always right click on any icon and turn on your sketch tools, and it'll reappear. Alright, so let's go back. I'm actually going to put it up here. I'm going to dock it here at the top. Alright, so now I'm going to create the outer one. Okay, so let's do the same thing. Again, one of my favorite commands, the elongated hole command. Once again, I'll use the same center to center. Oh, and I forgot to turn off construction mode. That's okay. It happens. I'm going to click and space. So I got to change these two solid elements. So I'm going to hold on to the control key, select my elements to change to solid lines and not construction lines. There it is. And click and space. Okay, so next thing we need is to close off our profile. Notice this is a construction art. I don't want to delete them because it may actually affect the rest of my profile. So if I was to delete this arc, I'll probably lose the tangents. Well, I will lose the tangency, and my sketch will no longer be it will no longer have a relationship, may not have a relationship between the other elements like tangencies and parallels, etc. So I'll just leave these arcs alone, just turn them into construction elements. Alright, so now let's draw the line to close off our profile. So we need these lines here. Okay, so I'm going to create a solid line. This tangent point to this one. Do the same thing on the other side. Use the line command. And there we have it. Click and space to deselect. So we need this radius of 175. I forgot about the radius here, 175. So let's go back. It's actually this dimension. Here it doesn't appear as a radius. It's the distance from this center to this point. So any point from the center, so if we start at the center, go to any point along the arc, has to be 175. So we can use this as our radius. Double click, type in a 1.75, and OK. Okay, let me zoom in a little bit, and there we have it. So we're pretty much done with this sketch. We can do a tool sketch analysis. And it's closed. We can go ahead and close it off, and we can exit. Okay, and now we're going to do our pad. Okay, so let's do a pad. Okay, and I'm going to click on mirror option. So it'll mirror it in both. So it'll mirror also in the opposite direction. So we're going in two directions about the YZ plane, right? If we turn off the mirror option, it only goes in one direction, as you can see. Turning on mirror, we'll mirror it over to the other side. Okay, and I don't know the length, so I'm going to have to go back to our reference one, our first one. Okay, so let's go back here, and we can exit this sketch. So once I click on this one, I can go ahead and exit the sketch. I can double click on the pad to get that number, or you can just follow along in the textbook. Okay, so 1 inch. All right, so 1 inch. Hit OK. Now I click in this window here. Go back to my new one. Double click, and it's a 1 inch length, which is mirrored, and OK. All right, let me go back to the first one, and you know what? Let me give it some color so we don't mix it up with our new one. So I'll give the old one a little bit of color. Okay, there we have it. All right, so now we're going to do a tritangent. Okay, so let's right click define on this one to see how it was created. There it is. There's our tritangent. So we're going to round off both of these here, to these flanges. All right, so tritangent will automatically calculate the radius on its own. It's basically taking the distance between these two parallel planes, cutting it in half, and that'll give us the radius. So this is called a tritangent, right? Because it's tangent to three walls, right? So tangent to all three walls, and that defines our radius. So we don't have to type in a radius. All right, so let's go back to our problem, and we're going to create a tritangent. So go to fillet, go to the drop down, and click a tritangent. Click on it. Okay, so we got to pick the outer surfaces first. So there's our first surface, second outer surface, and then the last one is the one in the middle, because we're going to remove that third surface completely, just like you see on the left. The flat surface here is completely gone. So we pick that middle surface last, the surface to be removed. Click, and it turns a dark pinkish color, and we can preview, and you can see it's going to do a tritangent arc, or fillet I should say. It'll be tangent to all three surfaces, and hit OK. And obviously we're going to have to do the same thing on the other side, right? Okay, so tritangent. And there we have it. Okay, so we're almost there. Let's go on to the next one. Okay, so we took care of the second tritangent. There it is. Now we're going to do a hole. Let's right click define. So we're going to do a hole going through both flanges here. Okay, so let's go. Actually, you know what? Let me get that dimension. Might as well, since we're here. So that dimension is 0.75 diameter. Notice it goes through last. It goes all the way through the entire solid. Okay, so let's do it on our new problem. Okay, so what we're going to do is pre-select one of the arcs. It can be any of these 4 arcs, and that'll help us center the hole to the existing arc. Okay, so I'm going to pre-select the arc, click on hole command, and I know the hole is centered around here, but I'm going to just click away just to show you that it will center it to the arc. So I'm going to click up here, but notice how it automatically moves it downward so it's concentric with the arc we chose that we pre-selected. Okay, and we're going to type in 0.75 for the diameter, 0.75, preview. There it is. Notice it's not going all the way through, so we're going to say, hey, instead of giving a blind dimension, a distance, I'm going to say go all the way through, up to last. And OK. Alright, so let's go on to the next one. Okay, here we have a plane. Let me define this one. And where is that plane? Okay, so here we have a plane. Excuse me. So we're going to create a plane. Now, typically you don't want a plane instead of a part body. We'll make an exception. The proper way is to actually create a geoset. Geometric set is, think of it as a divider in a folder. If you place the plane inside the part body, it's okay. But if you want to do it correctly, you should put it in a geoset. So I'll leave that up to you if you want to put it on a geoset. I'm going to follow a proper modeling technique. I'm going to create a geoset. Let me click here in my new part. I'm going to insert geometric set. Again, think of it as a divider on your folder, just like you have a divider, one for math, one for art, one for drafting, one for your English class, etc. It's just a way to stay organized. So I'm going to insert a geoset, and I'll just let it default as far as the name. It'll just call it a geoset 1, unless you want to give it a name like master geometry or working geometry, etc. You can give it a name to your folder. You can label it. I'll just let it default to geometric set 1. Notice it's underlined. Alright, so I'm going to create our plane. If this is not underlined, right click define, so that way it tells CATIA to put the plane in this folder or this divider and not the part body divider. And again, in part body you want solids or removal of solids like a hole command or pocket command to go in part body. Anything that's linear, curves, points, planes, surfaces, you put it in a geoset. Alright, so I'm going to go ahead and create a plane. Let's first find out what that dimension is on the plane. So we're going to offset of the XY plane. So here you can see the XY plane shown in orange. And we're going to go up 6.05. Okay, so let's create our own plane. Now the plane is probably buried in here somewhere. Let's see, and there it is. Yeah, unfortunately you have to take out the toolbars, and there's our plane command. I'm not sure if it's even in the drop down, and I think it may not show it in this workbench. Yeah, I don't see it. Yeah, but in the surfacing workbench, generative shape design, you would find spline, line, points, plane, etc. Here we have to actually dig for it, and there it is. So plane, we're going to offset off the XY plane. Now it's hard to see, but we do have an arrow that we can pull on. As you can see, right? We can guesstimate its location. We can pull on this arrow. Okay, and I think it was 6.05. And okay. Okay, so what we're going to do is we're actually going to sketch. So what's the purpose of this plane? Is to sketch the profile for the shaft. Okay, so, and by the way, I prefer to sketch on a plane than on a flat surface anytime. It's okay if you sketch on a flat surface on a solid. It's just better to sketch on a plane. Again, the reason I mentioned before I prefer not to sketch on a solid surface is because now our new sketch depends on this solid surface to exist always. If that solid ever gets altered or deleted, it may also delete any new sketches we create on it, making it dependent on the solid. Here our sketch will only be dependent on the plane. Okay, so let's go ahead and go to our next step, which should be the shaft. Yes, there it is. It is the shaft. Okay, so to create the shaft, we need to first create a sketch. And we're going to create a sketch with a circular profile of radius 0.6. Okay, so let's go ahead and do that. Let's go to our window here. Now we're going to create our sketch. And we're going to do it at the center, at the origin. So let's go with circle command. And we're going to, let me go ahead and turn off the light slightly in the background. You don't have to do this. There it is. So that's referred to as low light. Okay, and we're going to do a radius of 0.6. Change it over to radius and type in 0.6. Okay. And we're going to go ahead now and exit the sketch and create our shaft. Okay, so we're going to create a shaft. And anytime you create use the extrude or pad command, it always goes perpendicular to the sketch. So obviously it's going to go in this direction, or going upward, it's going to go in the Z direction, right? Okay, so let's go ahead and create a pad. Oh, I completely forgot. Let me cancel. I forgot that we were in GeoSet, right? So anything I created that's new will move into the GeoSet. So I'm going to move the sketch over to the part body. So let's say you did your math homework and you placed it in the English section, right, of your binder. Like, oh, I got to move my homework over to the math section of my binder or divider, right? So what I'm going to do is I'm going to right click and I'm going to cut my sketch. I'm going to paste it in the part body. Right click and paste. So all I did is simply move the sketch from one divider to another. Okay, there it is. So that's the reason I got that warning, is like, hey, you're trying to do a pad, you're trying to create a solid inside the GeoSet. So the reason I got that error message was because the GeoSet was defined, telling CATIA anything new that you create is going to go in this divider. But it's giving me a warning, hey, you're trying to create a pad which cannot exist in a GeoSet. It can only exist in a part body. So any new solids you create or removal of solids has to be done in a part body. Alright, so let me right click define on part body so I don't get that error message again. So anything new we create will go in the part body. So I'm going to create a pad of our new sketch. Notice it's going in the wrong direction, so I can always hit the reverse button. Okay, I can either put a dimension. Let's see, that's around 2 inches. I can always put a dimension. But the proper way of doing it is to say I want to go up to a surface. So instead of putting a 2-inch dimension, which seems to be pretty good, it buries itself in there. Let me hit OK, or you know what, let's hit preview. There it is. So that actually looks pretty good. But to be on the safe side, I'm going to say, you know what, instead of giving it a dimension, I'm going to say go up to surface. Okay, so I'm going to change the option here. Go up to surface. Actually, you know what, let me go back to dimension and let me change it back to 1 inch. Preview, because I want you to see visually how it goes up to the surface. Okay, so I'm going to say, alright, let's go up to surface. Click the solid, and notice it goes up to the surface. And it stops there. As soon as it encounters the solid, or the surface on the solid, it stops. Okay, hit preview, and you can see it ends right on the surface. And OK. Now the cool thing, and I think it is mentioned in your textbook, is if you take this plane, if I double click on the plane and I change the dimension, notice the sketch and the shaft will move with it. That's why I prefer to sketch on planes. Okay, let me go ahead and cancel that. Alright, so let's go back. I'm going to go ahead and exit. Okay, so next step is to create a chamfer. So right click define. So it creates a chamfer at the top here. I can double click here and we can see it's a 0.15 chamfer at 45 degrees. Okay, so let's do the same thing on ours. Okay, so let's create a chamfer on this edge. Make sure you pick the edge. There it is. And we're going to use a 0.15 chamfer at 45 degrees. Preview. So what is that 0.15? That means from the edge, actually it's showing it here, it's hard to see. From the edge to this orange profile, it's telling us, hey, we're going to create a chamfer, cut from here and cut at a 45 degree angle. And okay, there it is. Alright, let's go on to the next one. That was pretty easy. So now let's do a fillet. Okay, let's right click define. Now we're going to do a fillet going around. Okay, so let's double click. So that's a fillet with a radius of 0.2. Okay, I'm not sure why it's giving us this error message. That's alright, I'll just cancel. So it's a 0.2 radius. I'm going to hit cancel. I think I must have misclicked something before double clicking on the fillet, but that's okay. Now let's go to ours. Yeah, I was able to exit, so it's okay. I can just ignore the error message and just exit or hit escape on the keyboard when you get an error like that. Alright, so I'm going to go to fillet. Notice it was on tri-tangent. It remembers the last fillet type that we used was tri-tangent. Let's go to edge fillet. Pick the edge. Notice how it goes all the way around. Even though I only clicked one edge, it recognizes tangency and keeps going all the way around because we have it set to tangency. Now if I would have said minimal, okay, then it's gonna create the fillet and eventually it'll get to a stopping point where it can no longer continue on, right? Because we said minimal. Make the minimal fillet that you can create and stop. Let me hit preview. I'll come back to this. Let me hit OK. Actually, let me type in the radius of 0.2. I'm going to say OK. Notice how the fillet stopped, right? It stopped going all the way around. But if I double click on the fillet and say, you know what, I want you to go all the way around, keep going till there's no more tangency. So I can go from minimal to the default tangency, and notice how it's showing in red that it's going to continue going on. We can see by these red dash construction lines letting us know it's going all the way around, because as long as there's tangency, it keeps going. If it encounters a sharp corner or 90-degree turn, it'll stop there. But we don't have any sharp corners, so we can say okay, go on, and there's our fillet. Oh, sorry, I misclicked here somewhere. Okay, pretty good. Alright, let's go on to the next one. So we have another fillet up here. That fillet is also 0.2. Now, since they do have the same radius of 0.2, as you can see, let's see if it accepts it. So instead of having to create a new fillet, let's see if I can just go back to the first one, the original one. There it is. And see if it allows us to pick another profile. Notice we have one edge that kept going all the way around. Well, actually, you know what? I just realized we forgot the inside edge. Let me cancel. So let me take a step back. I actually forgot about this fillet. Completely forgot about the inside. Okay, so let's take care of all the fillets in one shot. So I'm going to click on this fillet. Hey, let's do the same thing with the inside edge. So it's going to go all the way around. Preview. And okay. There we have it. Okay, so we have the double fillets, right? Let me double click again on our only edge fillet, and now let's see if we can pick this one. There it is. Notice I did not pick the surface, I picked the edge. If I look here in my goodie bags, see it says we have chosen 3 edges. Not surfaces, but edges, right? And hit OK, see if it accepts it. And it did accept it. If for some reason these fillets fought each other because they're kind of close to each other, almost blending into each other, if I would have gotten an error message on this third one, then I would have just created a new fillet just for this one. Alright, let's go back. Okay, so now we're going to create a sketch. We're going to create this line because we're going to add a groove. And again, I don't recommend putting sketches in part bodies. If you do it, it's okay, but it's not proper modeling technique. Alright, so let me exit this sketch. So what's the purpose of this line? So the purpose of the line is to create this groove, right? So we're going to create a groove. So we need a direction, a line. And we're going to need a starting point. There's our sketch. So we're going to have to create a sketch of the groove and a sketch for direction. Let me turn on the slot profile. And actually, let me take a step back. When I said these sketches should not be in the part body, that was incorrect. I was thinking line command. I was thinking planes and lines. So when I saw a line, I was thinking line command, but this was actually created in a sketch. So it's okay if it's actually done in the part body. But if I was using the line command to create this instead of a sketch, then I would have placed my line in the geoset. But since it was created in sketch, we'll leave it in the solid, in the part body. Alright, so actually here's our sketch down here, as you can see, for that groove. There's our sketch. Then we have this line to give it a direction. Okay, so the line gives our sketch a direction and a length. Alright, so let's go ahead and create our slot path. Okay, so we're going to create a line. So here's our line with the given dimensions. Okay, so we have 0.5 and we have 4.5. So 4.5 from the horizontal to this endpoint. And then it's 0 from the plane. It's hard to see, but we have a 0 dimension here. There it is, 0 dimension. This endpoint to this plane has a 0 dimension. And then we have 0.5 from our vertical to the line. So that's the offset dimension. Alright, so let me click normal so I can straighten out my sketch. Okay, so we're going to create a sketch on. Let's find out. Right click on the sketch. And I'm looking for parents and children. There it is. So we're going to sketch. Oh, it doesn't. This one shows that it's sketched on. So these are the parents. As you can see, this is telling us we're going to offset from a plane. So I was hoping I could see the parent plane. Let me cancel. Let me exit. Let me right click parents again. There it is. I don't know why I didn't show the plane earlier, maybe because we're in sketch mode or sketch workbench. So we're going to sketch on the ZX plane. Okay, so ZX. So here's the ZX plane. There it is, ZX. Okay, now it highlights it. All right, ZX. Okay, so I'm going to go over here and make a sketch on the ZX plane. And once again, we're going to create a line. So I'll just randomly create a line in space, vertical line. Then I'll come in and add dimensions. Okay, so there's our line. And we're going to put a dimensional constraint from the horizontal to the bottom endpoint of 4.5. So that point will give us the starting or the bottom of the groove. Okay, now we need to constrain this point to something. Now, the reason we constrain this point to the existing plane, here's the plane. Actually, let me turn it more so you can see it. So here's our plane that we sketched our circle for the shaft. So we want this endpoint to always be tied to this plane. So if this plane ever changes in height to change the length of the shaft, this point will always travel with this plane. Okay, so that's the reason of tying it to the plane. If this plane ever moves vertically upward or downward, this endpoint will go with it. It'll stay anchored to it. So we're going to put a dimension from the plane, or we can do the top surface. Either one will be acceptable. I prefer the plane. The plane is the parent of the shaft. Okay, and go to the endpoint. Okay, there's our dimension, and change it to 0. Okay, there it is. So notice now that endpoint is in line with the plane or the top of the shaft. Either one is acceptable. Okay, now we need a dimension from the vertical axis to our line. Okay, let me click normal. Okay, let's put a dimensional constraint from the vertical to this line. I believe that was 0.5. And OK. Okay, so this is the path of the groove we're going to create. Okay, so now we need to create a sketch for the groove, which looks like a trapezoid, I believe. Okay, so let's go ahead and exit this sketch. And there's our sketch. Okay, so yeah, the comment I made earlier, like, hey, let's put this sketch in the geoset. So sketches can go in a geoset or a part body. But if you're going to use that sketch to create a solid or to create a void on a solid, then you definitely want it in the part body. If you're going to create that, if your sketch is not going to be meant to be used to create solids or remove from solids, then you can put it in the geoset. Alright, but in our case, we're going to remove from a solid, so we'll leave it in the part body. Okay, so now let's create our next sketch, which is going to be on the XY plane. If we look at parents, oh, that's too big. Let me. There it is, the XY plane. So the XY plane is the parent of the slot profile, which is a trapezoidal shape, I believe. Okay, so let's go ahead and create a sketch on the XY plane. But let's first take a look at the one from the reference model, slot profile. And there it is. And let me darken the background a bit so we can see it. Turn off light. Okay, so that's the profile we're going to create. I know in the textbook it's very difficult to draw this profile because of the lighting and the solids in the background. That's why I go to low light. You don't have to do that. Alright, so I'm going to pick the XY plane. I'm going to create a sketch on it, just like the one we see on the left. Let me zoom in. And again, just for to drop the light, I'm going to go to low light, because I know seeing all that in the background is hard to see our profile. Let me go to low light. There it is. Okay, so we're going to create this trapezoidal shape. Okay, so go to profile. I'm going to try and keep it symmetrical about the vertical. Oh, don't want an arc. So yeah, it's trying to create an arc. So in Sketch Tools, anytime you're in Profile command, It may jump to an arc or line. Let's go to line. And actually, I should be further out, so I'm actually going in the wrong direction. Let me go in this direction. My dimensions are off, but that's okay. We'll come back and fix it. Make sure I'm normal. There it is, normal to screen. All right, so now let's add some dimensions. So from the horizontal to the bottom. And type in 0.5. The next one is 0.2. Oh, must have mistyped. So I got an error message because I probably typed in a symbol or something that I wasn't supposed to and it rejected it. 0.2. Here it is. Okay, so we also have a 0.2 on this one. .2. Okay, so things got a little off, right? That's okay. Why did it do that? Because when I added a new dimension, it suddenly shortened this length, and everything else will follow along. It'll take the path of least resistance usually. Okay, so now I gotta do symmetry. So here we have symmetry. So this is the symmetry. It's symmetrical about the vertical. Okay, so let me go back to our sketch. I'm going to hold on to the control key on the keyboard. First select the two lines I want to be or make symmetrical about an axis. In this case, it's going to be the vertical. It doesn't have to be an axis, it can be a line. For us, we're going to use the vertical axis. Again, I'm holding on to the control key, and make sure you pick our vertical axis last. Okay, and then I'm going to put a relationship constraint of symmetry. Let me move it over to the left. Symmetry, and there it is, symmetrical, and OK. Click and space to deselect. Okay, now notice if I was to grab this corner, notice it's still not fully constrained, and we're missing something, right? It can be a length, it can be an angle. Let's go to our sketch on the left, and it's hard to see, but there's actually an angle here of 115. Okay, so we have an angle of 115, so we're going to add a dimensional constraint. Yep, looked like I misclicked. Let me try it again. Click and space to deselect. Dimensional constraint from this line. Let me zoom in. From this line to this line. Okay, there it is. And we're going to make it 115 degrees. And there it is. There's our sketch. Alright, so pretty straightforward. I know on the textbook it may not be very clear because if you have a textbook, most likely it's printed in black and white, and it's hard to see the profile. If you have the colored version, the e-version, you can actually see the color, and it's a lot easier to see this. Okay, so again, the ebook version is in color, which I prefer, obviously. So alright, so let's go ahead and exit the sketch. Okay, and the sketch is down here, as you can see. They're at the bottom. Okay, now we could have done our sketch on the plane. It actually would have been easier if we did it on this plane. But here the author wants to show you how, using this line, the line will control the length of the groove. Alright, so let's go ahead and create our pocket. So let's go back to this one. Let's go ahead and exit this one, exit the sketch on the left. And it's going to use the pocket command to create that groove. We can also actually use the slot command. Okay, so let me deviate slightly. So I actually don't know if this meant to be use the slot command, but in this case, either one will work. Typically, you want to use slot on curved paths. Okay, so Good example is threads on a bolt or a nut. Here, because it's a straight shot or linear path, a pocket will work. Okay, so let me go ahead and cancel. Alright, so instead of using pocket, I'm going to use slot. Okay, so I'm going to create a slot. Our profile is our quadrilateral here. Okay, so I'm going to pick this sketch. Our center curve, that's the path, will be this line we created in our other sketch. Click. And notice it's already creating the groove. Preview. Oh, it's unnecessary. Okay. Alright, so let me hit OK, see what happens. I'm not sure what's going on, but we're going to find out. And OK. Okay, I think I know what happened. It seems like the sketch or our groove is actually buried in here. Okay, I know what happened. So what happened is it's taking the groove and it's only following the path, but it's not following its endpoints. So you can see here's the groove. So it's following this length. So it is following that length correctly. So I need to go in and make some changes. Okay, so I need to fix this. My mistake. So let me cancel that. Let's see. So the groove is there. It's actually there, but it's cutting through space, which that's why we got the error message. So let me go back to our first one and see what they did. Actually, what I did years back when I first created this as a student. So when I was taking this class as a student, I created my parts, so that's what I'm showing you. Okay, so so here's the limits. So with the pocket command, you can put limits. Okay, so that's the reason the pocket was used. Okay, so I'm going to cancel. Let me go to slot, see if I have limits as options. Oh, and I actually don't. Okay, so now I see why the author did not use the slot command and use the pocket, because you can set limits using the point. So let me cancel out of here. Okay, so I'm going to delete the slot, or you can just hit undo if you like. Okay, so if I hit undo a few times, it'll get rid of the slot and I'll be able to still keep my sketches. There it is. So I hit undo enough times to come back to my sketches, right? Now if I go back forward and said, you know what, I don't want the slot, but I want to keep the sketches, I can always right click, delete the slot. Okay, you have to have this option on or off, and I forget which one it is. Let's see if it deletes the sketches if it's on. If it does, I'll come back and uncheck it. And okay. And it did delete the sketch, right? So let me hit undo. Control Z, undo. Or you can always click undo here. So this time when I delete the slot, right click delete. Turn this option off, or else it'll delete any aggregated elements, right? Nope, I don't want to delete aggregated elements. So okay. And it keeps the sketches. Okay, there it is. Okay, so let's use the pocket command. Let me go back to this one, because I actually don't remember how it was done. Okay, so we're going to use our shaft plane, which is this one. And I didn't label my planes, and that's probably what's giving me problems. I forgot to label planes. Okay, so I'm actually missing plane number 2. Okay, so I need to bring in some new plane, a second plane. So let me do that first. Okay, so let me actually go back and label. So I did a poor job of not labeling. So let me go to this plane, properties, right click properties, and we're going to call this the shaft plane, right? That's where we draw our circle for the shaft. So I'm going to go here to feature properties and call it shaft plane. Okay. Okay, so I'm going to go to the line sketch. This is our line sketch. Right click properties. And that's called the slot center curve. So that's a straight line. And then we have our profile sketch. So right click properties. And then we're going to call that the slot profile. And that's the quadrilateral. Okay, so as you can see, this is the slot, and then the other one is the line. Okay, notice how this is underlined. I actually want the part body to be underlined, so I'm going to right click defined. Okay, I want to make sure I'm in the present and not the past. Like here I am in the past, right? I haven't done the circular pattern yet. Okay, so let's go ahead and do our next plane. So this plane is normal to this point. Alright, so we're going to create a plane normal to this line at that endpoint. So let me cancel out of here. Okay, so we're going to create a plane. I'm going to put it in the geoset. You don't have to, but I am. Right click define. So I'm going to put a plane, create a plane, normal to a curve. Okay, so let's go down to normal to curve. I'm going to my mistake, select the line from our sketch, right? Notice it automatically centers it. Okay, so the midpoint, so it defaults to midpoint of the line for locating it. I'm going to pick the endpoint down here and moves it down. There it is. So this plane will always adjust to the length of this line. If this endpoint on the line moves, the plane will move with it. Okay. Alright, so let me give our plane some color because I know it's hard to see. You don't have to do this, but I want the planes to stand out. Okay, there's our planes, as you can see, in cyan. Alright, so let's go ahead and do the pocket command. So I'm going to do pocket command. Pocket. Oh, notice the geoset is underlined, so that's why it's giving me the warning. So I'm saying, hey, it's in the wrong place, but we're going to put it in the part body. That's what the error message was telling me. It was going to say, hey, I can't put it in here. It has to go in the part body. So let me right click define. I know this is annoying, this back and forth, but it's important that you stay organized. Okay, so let's do pocket command. Pocket. Okay, so we're going to pick our profile. And actually we don't have to pick a direction. We don't need to use the line, but we do need to use the planes that are tied to the line, right? Okay, so I'm going to say, hey, I want to go up to a plane. Up to a plane. I'm going to go up to this plane up here. Notice the slot is going up to that plane, as you can see. Preview. But notice how it's going all the way through the part. We don't want the slot to go all the way through. Notice it's coming out to the bottom. We don't want that. Okay, so now we're going to go more to provide a second limit. So I'm going to pick up to a plane for our second limit. So obviously the first one was the first limit. Now we are in the second limit. Our second limiting element is the plane. Click this. Preview. And notice now how the slot is right between the two planes. This plane is defined by that endpoint, and this endpoint is defined by that plane. So they're all connected. And okay, and there's our slot. Okay, so all we need now is the circular pattern. Right click defined on this one. So we see a circular pattern going around the z-axis. So it happens that the z happens to be centered, right? Because we did everything symmetrical about the origin. Okay, so circular pattern. We're going to do 45 degrees spread over So 45-degree increments spread over 360 degrees total. So we're going to do a complete circle of 360, obviously, and increments of 45, and it'll calculate the spacing on its own. It's going to say, oh, 360, 45-degree increments, we're going to create 9. Alright, so let's go ahead and cancel out of this one and create our own. Okay, so once again, let me right-click define the part body, right-click define. Now we're only going to do a circular pattern on the slot. So we're going to pre-select the slot. I'm going to pre-select it by just simply clicking once. Then I'm going to go over to the circular command. And I'm going to go around. So let me left mouse click in direction. I'm going to right click and go about the Z direction, the Z axis. Notice it's going around the Z axis. Okay, and we're going to change the option over, I think it was angular spacing, using a total angle of 360. So we're going to pick the third option. So we're going to go 45 degrees. Every 45 degrees we're going to have a slot over an entire 360. And preview. So here it's telling us, hey, one of the slots is going to actually land on top of the existing one. So that's why it's giving us a warning. Hey, you're actually creating an extra slot that happens to land on the original one. Like, all right, thanks for the warning. We'll just accept it. Yeah, because we have 1, 2, 3, 4, 5, 6, 7, 8 total slots. So notice it's showing, hey, you have 9. The 9th one is on top of the first one. So if you want to clean that up, I mean, you can leave it alone. It's just a slot on top of a slot, which is not proper modeling technique. So we can do the math here and say, okay, let me, instead of going 360 all the way around, I'm going to go 360 minus 45. So I don't have that 9th slot on top of the original one. So I'm going to go in here. I'm going to hit the backspace to remove the DEG, the degrees. Then I'm going to go minus 45. The reason I remove the DEG is because if I have 360 DEG, then I have to go minus 45 DEG. The units have to match. So I'm just going to remove the DEGs and let it do the math and insert the DEG on its own. So now I'm going to click away. Click away. Notice it does the math. 315. So 360 minus 45. And it automatically will give us 315 DEGs that inserts the degrees. Okay, so now we can say preview. Now we don't get the error message. So now we have 8 slots, right? We can see up here we had 8 when previously we had 9. Alright, so we're going to hit OK. And we can click and space to deselect. And we're actually done. Now the second one, you can follow along the textbook and create the second one if you like. What I'm going to do is cheat. I'm going to save this. Okay, so I'm going to go ahead and save this file. And what I'm going to do after I save this, I'm going to save a second copy and call it the lower. Okay, so this is the top U-joint, right? Top U-joint. And I called it number 2 because I already have an existing one. So I'm going to save this as top joint number 2. Save it. And I'm going to cheat. Okay, so it's saved as top joint, right? Number 2. And I'm going to create a second copy. Now I'm going to file, save as. So I'm creating a second copy. And I'm going to call it the lower. Okay, so I'm going to save a third copy. So I already have my top, and then when I hit save, it's going to save this as a lower U-joint. Then I can alter it and follow the textbook for the second U-joint, or I can just leave it alone. Okay, so I'm going to go ahead and save. And in the next video, I'm going to show you how to put it all together. Okay, and that'll be in the next lecture, which will be covered in the next class. So for this session, we just wanted to cover the swivel, which we did on the previous video, and also create the U-joint. Okay, obviously my computer's starting to freeze up for some reason, so I'm going to go ahead and end this video, and I'll see you at the next one.